In this video, we are going to write the code for UVM test, and let's begin. So UVM test is even more top in hierarchy when compared to the environment. And as you have watched my previous video where we wrote the code for the environment, uh, we just mentioned the instantiation of the agent and the scoreboard, and then we did the connection between the analysis port which is present inside the monitor to that of analysis import which is present inside the scoreboard. So in this video, what we will do is that we will create the class for the test, and inside the test we will have two instantiation. The one will be of the environment, and the second one will be of the UVM sequence, which is an object, unlike UVM environment, which is a component. So let's begin. So I will name this class as test, and it should extend UVM test, the inbuilt class from the UVM libraries. Now I will do the factory registration, and this is also an UVM component. So I will use UVM component details. And then inside I will write test. So here we have to create the objects for UVM environment and the sequence. In our case, the name of the sequence class is sequence1, and the name of the environment class is env. So let's begin. I will name the handle of the environment as e, and for the sequence I will name it seq1. So after we are done with this, the very first thing we will do is to create the constructor. And inside this, we will just call the constructor of the parent using the super. Now we are done with the constructor. Now we will move on to the build phase, and inside build phase, we just have to create the objects of the environment and the sequence using the create method. First, I will create the object for the environment class, and the name of the handle is e. So I will just write e equals to the name of the class, then type underscore id, Then using the scope resolution operator, I will write create, and then it should have two arguments. First argument will be the string, that is the name, and the second argument should be the reference to the parent. The reference to the hierarchy. And for the sequence, it will have only one argument. Since it is an object and object is dynamic, there can be multiple copies of object, and in our case there will be multiple copies of sequence, because as you can see inside the sequence, uh, there will be only one copy, but it will be randomized for 10 times in a row. But you can have multiple copies. Suppose if I moved this the create method inside this repeat loop, so there would have been separate copies, and it is dynamic. The name of the handle was seq1. Now I will begin with the run phase, and we have some important things to do inside the run phase of UVM test. Now the very first thing we have to do is to write the raise objection and the drop objection, and I will tell you why. So to write that, you have to write phase, then you have to refer to the raise objection method, and inside the raise objection you have to mention the class, and I'm going to be referring to this class since this raise objection belongs to this UVM test, so I will write this. Similarly, you have to write the drop objection, and between this you have to start the sequencer using the sequence. So before that, let me tell you something about the raise objection and the drop objection. So if you do not write the raise objection and drop objection, the entire simulation will just end. It will just terminate without doing anything meaningful. So it is important. It is kind of a time frame that everything will happen between these. And phase and also it is important for the synchronization between different phases. And also, if you somehow forgot to mention the drop objection, the code will keep on running, and right after that, after some time, uh, it will call a fatal, and in fatal it will just quit the code with a fatal error, and the current time limit is 9200 seconds, and you can set it using one of the method present in UVM top. But for now, let's just stick to the basics. And between the raise objection and drop objection, you have to start the sequencer which is present inside the agent, an agent is present inside the environment. So you have to start that using the sequence. So first, I will write the handle of the sequence, which is seq1 in our case, and then you have to write the dot and you have to use the start method, and inside the bracket of the start method you have to refer to the sequencer. So the sequencer is present inside the agent class, which is present inside the environment class. So the handle of the environment here is E. So we will write E, then dot, then let's look for the handle of the agent. So the handle of the agent inside the environment class was A. So then we will refer to A. Then we have to refer to the sequencer. So let's open the agent class and let's find out what was the handle of the sequencer class. So in our case, you can see it right here that the handle of the sequencer class is seqr. So then we have to write seqr. So that is the main thing. But after that, just to make sure that the entire code runs successfully before closing, you also have to give some delay for monitor and scoreboard to do their stuff. So as you can remember that there is a handshake communication going on between the sequence and the sequencer and the driver. And here I gave a delay of 10 time units, and inside the monitor, inside the run phase of the monitor, just before I started receiving the response from the duty, I gave the same delay. So after this delay, only after this delay, the monitor will collect the response from the duty, and then uh, using the analysis port, it will connect to the analysis import of the scoreboard, and it will pass the data using the right method, or the response using the right method. And inside our right method, we wrote a simple checker because our design is itself very simple. So here you can see that there's a delay of time unit, 10 time units, or whatever you want to say, a 10 time literal. So if you do not give a delay of at least of 10 time literal, then the phase drop objection will get reached, and the last instance, because here you can see that there will be 10 randomized copies of of the sequence class. So the monitor and the scoreboard, the checking for the last class will not be done, because before that the phase drop objection will be called and the simulation will end. So this drop objection and raise objection works accordingly as per the communication which is going on between the sequence and the driver, specifically between the sequence. So here we will just give here, not here, here we will just give a delay of 10. So this will allow the um, monitor and scoreboard to work for the last packet that will be passed. So using that, our UVM test is complete. And after that, we have to write the top level test bench, and it does not use any UVM class. It is straight up a module, a test module, just like your regular test bench. So I will write that thing in my next video. So in UVM test, you just have to mention the instance of environment and the sequence, and there can be multiple sequences. It depends upon you that how many test cases you want to write and whether you want to separate them into categories or not. And then you have to do the simple stuff that you have to create the object for both the environment and the sequence. And then the run phase of the test is unique as compared to our previous class, because here we are using phase raise objection and the drop objection. And this is the way you write raise objection and drop objection. And this is important to hold the simulation so that the different phases of different class can do their work. And between them, you just have to use the right method for the handle of the sequence to start the sequencer, which is present inside the agent, which is present inside the environment. And remember to use handle for the reference. And after that, just be a little generous and give a delay of at least at least the same as you have mentioned right in the beginning of the run phase of your monitor. So that's all about UVM test. I hope you find this video useful. Stay tuned for more. Thank you so much.